So please let me check it to share whole screen instead of only this one. Okay, so basically we have a kind of group that we want to discuss the data science and everything that is related to data science, and also something that is related to finance, maybe some aspects of finance for the people that they are specialists in this case. And in this group, we have book club, and we choose this data mining and predictive analytics as the first book to read it together and discuss it together. So the plan is like this, that we have half an hour for a presentation of a chapter of the book. It's done by one volunteer. And after that, we have half an hour to discuss, to discussion and discuss everything related to that chapter. Let me go to the plan. So this is the chapters of this book. As we know, the chapter 1, chapter 2, chapter 4, 7, 10, 11, 12, 13, 14, 15, and 25 are selected because they are related to the course of data mining. For the first session and the second session, I took the responsibility to present the chapters. For chapter 4, we have now candidate, Anna, and for the other chapters, we are waiting for the people if they are interested to present something. And this kind of presentation is very friendly presentation. So it's not something that we have to say everything about the points and very important parts of that chapter. We only review the chapter and make a summary. So it's very easy. Only read the book and then mark some points that we think that they are important, and then present it. As simple as this. Then we can discuss it together if we have some idea, if we have some other resources, or if we find something on the Google, for example, on internet, or we have some books that they are interesting, we can share it, we can tell each other about that. Or maybe I know a point about that subject and I can share the idea. So the discussion is also as simple as this. We can see the group, okay? So this is the main page of group. And if we scroll down, here we have online book club. What we have here, we have the comments. So we put everything in the comments, and we have the first book here. So we add all of our ideas, all of the questions, all of the resources as the reply to this one, to this first book, data mining and predictive analytics. So if you go there and load all of the comments, you will see that the plan is here. So you can look at this and reply it that I'm interested in this chapter, and then that chapter is yours. Okay, if you are interested, anyway. Okay, so in this chapter, the main idea is a model that we use in data mining sometimes. So the name of the model is CRISP-DM. This is the standard process to how to start with gathering data till deploying the model. If we go to next page, we can see that here we have the need to pre-process the data. So the main idea is that the data that we have is not clean. We have the raw data. So it is pre-processed, it is incomplete, it is noisy, and we have to do something about it because garbage in, garbage out. So this is the main rule. And here, something that is very important is missing data, something like, for example, missing data, the outliers, also the absolute or redundant variables, the fields that we have in our data set, the data in the form of something that is not suitable for our model, so we don't need it, or the values not consistent with the policy or common senses. We have to do the data cleaning and we have to pre-process the data, but we mainly divide it into two groups. One group is data cleaning and the other one is data transformation. So mainly we have two parts. that they are different, the data cleaning and data transformation. Maybe in data transformation, we make some other variables or attributes. So it's a kind of process in data engineering that we do it to make some valuable variables as an input to our model. So if we have a model, the input is important. Maybe we can combine some of these variables and make a new variable, but it is more informative. So we called it the data transformation. And we have also the data cleaning that is mostly related to missing values and outliers, preparing data. Everything that is related to data engineering is about the data cleaning and preparing the data for our process. So this is a very huge work. Based on this book, it said that it's roughly around 10 to 60%, sometimes 60% of our total job is about preprocessing of the data. So it's very huge work sometimes because the data is not clean at all, and the data also is very important. So we are going to data cleaning. That's what we mean with data cleaning in this book. We have a kind of example that we had it in the class. So some of you are familiar with this table. Here we have some missing values. As we can see, some of the values here are not similar to others. Here we have some values for example, M as merit, for example, or W or S as T. These kind of things that they are not clear what is the meaning. So maybe here we need some kind of data about data, like we called it metadata, right? So we need something that discuss for us that what is meaning of M, W, S, T, etc. Okay, and the other parts, for example, here we have 0, but here we have C, and here we have negative for income. These are the errors that we can find here in this data set, and all of them are important to be reviewed and taken action. The next part is about handling the missing data. Basically, I prefer to start with outliers before missing data. And there is a logic behind of that because the outliers, sometimes we remove them from our data set and then maybe we treat them as the missing data, okay? And also the other important point for this is when we remove the outliers, the data set is free from these noises, okay? From the outliers that they are not belonging to our data set. And when we want to treat the missing values, the imputation that we choose puts some values that they are valuable. They are based on the true information because we estimate sometimes the missing values and the missing data. And if we have some outliers, they make some bias in our data. But in most of the books, they start with missing data and then outliers. But we have to take care that this is not a kind of order that we have to obey when we are going to pre-process the data. We can change it or we can do it and go further and then turn back to do some other changes. So the order is not like this. Sometimes the people prefer to start with the outliers before the missing data, okay? We can replace the missing values with some constant. We can replace the missing value with the field mean. We can put the average. We can put the median. And we can replace the missing values with a value generated at random, maybe from the observed distribution, if we have the distribution, and replace the missing values with imputed values based on the other characteristics and other attributes that they are already recorded. So sometimes we find some correlation between the variables and we can use this correlation to impute the missing values. But there are some important points here that I will mention in my PowerPoint, okay? So here we are going only to review the book and the materials of the book, and then I will add something to this part. Okay, so here we have the different examples values with this method. The other action that we have to take is the identifying the misclassification. That if the classification that we have in our data is not right, or based on some information that we have, we know that there are some errors there, so we can go and make some corrections. The graphical method for identifying outliers, in this book, it used the histogram, but we know that we have all, the box plot, the PP plot. There are some other plots that they can help us, or some methods, and a statistical analysis, of course, some hypothesis analysis to find out that if outliers are really outliers or not. Okay. So here I put a note that there is a difference between extreme observation and outliers. So one point that I want to note here, and I want to mention, is the difference between these two. What is the difference between the outlier and extreme observations? Sometimes the people think that all extreme observations are outliers, and that is not true, because extreme values may or may not be outliers. Any univariate outlier, however, are always extreme values in the sample, but all of the extreme values are not outliers. So the opposite is not right. And we can remove outliers if they are observed by mistake or with no tangible reason. We can remove them. Or they are not fit to the data distribution if we have the distribution. And the business nature values, for example, can give us some clue that we don't have this number in our business, or it's not a logical value, so we can remove it. Or the information of the literature review, all the information that we gather in our literature review will tell us that this number could not be a correct one. So we can, in this, we can remove these numbers. And this is the difference between the extreme values and outliers that I will discuss more in my PowerPoint. Okay, so here we have in this histogram, we have this part. So this part is far from the other data that we observe. So in this case, we can imagine it as outlier, but this is candidate to be the outlier. We should have some proof that this is really outlier, and we cannot remove it simply. Okay, and sometimes we have observed this part of the distribution, but have not observed this part. Okay, and because of that, this is here. And in real world, we have some data here, but this is out of our sample. And because of that, we might say that this is outlier, but it's not really outlier. And sometimes the outliers has some important information inside that they are very important, and we should have take care of them. Because, for example, if you are studying something about disease, okay, the people that they are outliers in some characteristics, they have some important information that we really need them. So sometimes we can divide our data set into two parts and make another study, one independent study on the outliers. So this can be a solution for some cases when we are studying some sensitive things, for example, when we are studying the diseases, or we are studying something about the financial corporations like banks or insurance companies. So for example, the people that they default, they might have some specific characteristics very far from the other people. And this is important to know what is the characteristic of these people. So it's not like this that we simply remove them. Okay? So please interrupt me anywhere that you have one point you want to mention anything. Okay? So this is a fair discussion. All right, so here we have another example, and I have a question. This is our data sets that we have it in scatter plots. And here we have one observation, here we have another observation, and here we have some observations that they are not very continuous with the others. And what do you think? Which parts are candidates to be outliers?
What is 100, 200, 300 is the frequency of observation?
This is about the cars. So this is MPG, characteristics of the engine of the car, and this is the weight. So something like I think that the power and the weight. And from the data that we have here, we have two data that they are far from the others, and we have some others here that they are very close, but they are somehow with some distance. So what do you think? Can it be candidate as an outlier?
I think that's not an outlier. That's an error because of the weight. Well, if you are considering the weight, I think that's an error of the registry in the database. And I think the outlier is the other one that is about 2,500, and I think that's the one that is an outlier.
Yes, exactly. So as you said, this is not an outlier, this is a kind of error, and we can simply remove it. And what if we have something here? For example, if we have a kind of data, for example, let me put something here, okay? Now imagine that this is 1 point, for example. And if we have something here, what do you think?
Well, it might be. It depends on the rest of the data points, because it's more closer to the last one. So we can depends if we define a rule or whether we identify the two standard deviations rule for the definition.
Exactly, something that can indicate that this one is outlier or no. But basically, if we have some points close to the others, but it follows the trends, and the amount of that point that we are looking in our graph is not indicating any kind of errors, then we can keep it in our data set. Mostly it is recommended that keep it, even if you find something strange with that is far from the others, but it will increase the accuracy of the line that we want to fit to this data. Okay, so if the data that you are going to investigate it is following the trend of the other data, okay, but it's a bit far from of those, and the value is not an error, it's something that can happen in the real world, then it's better to keep it. It can show us some parts of the data set that we could not observe, but by chance we could observe one of them. If you think about, for example, the normal distribution, you know that normal distribution is from -infinity to +infinity, but mostly it is between -3 and +3, but it is probable to see something over 3, over +3, or over -3. So it's possible, but not so much. So maybe we observe only 1 or 2 points, and that's enough. And it can help us to show that what is the extreme values in our data set. Sometimes we cut the extreme values because we don't have any reason for that, and we think that maybe it is the outlier, but it's not really. But this one that is far from the others, and also it's not following the trend. So the trend is something like this. So this is the trend, and it is completely far from the trend of our data set. And we can consider it as outlier, and we can also test it with some statistical tests to make sure that it is completely inconsistent with the other part of our data set. Okay, so here it said that we have 2 outliers. I'm not very agree with Book here. I think that we have to have enough evidence from literature review or industry concepts, consider the second one as outlier, or it can be considered as a mistake, not as an outlier. Okay, so measures for center and displace. The book continues with the measure of the center and the spread. And what is the reason of that? Mainly in the distributions that we study, and the distribution of data is important for us because in the first session I discussed that we have a function in real world that we want to know about it. That function is not clear for us. The only thing that we can see is the data. So the data is coming out of that function, and that is something that we observe. And we want to make a guess that what is that function is. And these kind of functions, that they are functions related to probability. And as we said, if we don't have probability, there is no question there because we observe that for once and we have the answer, right? So if we talk about modeling, we are talking about probability. The probability is there. It is in the nature of our modeling. If we don't have probability, the answer is clear. We observe it once and forever it is like that. If we cannot observe it, it's impossible, right? So the probability is 0 or 1. But if we have the probability, we have the distribution. And for the distribution, if we know about the center of the distribution, and then how it is dispersed, okay, what is the variance around the mean and the center, then we can have the important information about that distribution, and we can calculate it and put it on the paper. So here it is important to know about the mean, about the variance. Another point here, in my point of view, is that the variance is something that shows us that how much information we have. Okay, so here we have another concept about why the mean and the variance is important. And here we have the formula of the standard deviation. And also here we have the data transformation. So the main part of this part is this sentence that data miners should normalize their numeric variables in order to standardize the scale of effect each variable has on the results. So do the transformation, sometimes it's because of we want to normalize our data, we want to make kind of comparison in our data set, and because of the difference between the scales, we have to normalize them. So it's a kind of transformation that we do. So here we have the min-max normalization. So for this kind of normalization that we want to put something in numerator and something here, and by this division, the scale will be removed. So if you find something like this, we can say that we have a way to remove the scales, and from then we can do our calculations. So z-square standardization, again, do the same thing. So we have x and the average of x, and here we have the standard deviation, and we know that we have a scale here, we have a scale here, and they will be removed from this division. And then the z-score is the scale free, right? But this kind of transformation has some other benefits that they make the data more close to each other. So if we want to have a kind of normal distribution, or we want to use the central limit theorem, or we want to have a kind of well-behavior distribution because of our analysis and the tools that we are going to use from statistics, sometimes it's necessary to calculate the z-score. Okay, this is another one, the decimal scaling. If we want to decrease the scale of the number. And here we have the distribution. So the normal distribution, that's something like this. And also we have the t-distribution, that is a kind of normal distribution with lower degrees of freedom. But if you want to indicate that if a distribution is the t-distribution or it is the normal distribution, mainly you should look at these tails here, okay? Here and here. And for t-distribution, the tail is heavy. So it is started from here. and also started from here. So it is not like this. If we have something like this, it is mostly normal, but we have to test it with a statistical test, of course. Okay, so the main characteristics of the normal distribution, as I said, is the average and also the variance. And here said that if we consider the weight as a normal variable, then we have to look for the shape of the normal. But here we can see that this weight is skewed to the right, or it is skewed positively. And here we have also another distribution that it is skewed also. So we can calculate this skewness to see that how much this distribution is far from normal distribution and if this is significant or not. Okay. So here we can see that if the distribution is skewed to the right, then the median and mean will not cover each other. But if we have the normal distribution, the mean and median and mode are all in the same position. But here we can see that the median is less than mean, and here the median is more than mean, right? So it is in the right of the mean value. So from the calculation of mean and median, we can find out that our distribution is skewed to the right or it is skewed to the left. And also we have some calculation for skewness. And also we have another concept as kurtosis that we are not going to talk about it here, all right? So here there are some examples that how they calculate it. And then we have some other charts that we can use them as the PP plot and the normal probability plot to see that if we have these tails here and this tail here, for example, then the distribution is not normal or it is far from normal. But if we have this kind of shape between these two lines, these two blue lines, that they are the confidence level, we can say that the distribution is normal. Okay, so the numerical method for identifying outliers, how we can identify outliers with calculation. Mostly we use the IQR or the PP plot or the box plot. So this is about the box plot and the quartile 1 and quartile 3. And based on these quartiles, we can calculate the range of the quartiles, and then by multiplying it to 1.5, we can find that which observations are over the positive one and which one is below the minimum one. And then based on that, we can candidate some of the observation as outliers. Now we have the flag variables. The flag variables are the dummy variables. Why we need the dummy variables? Basically, in the data set, when we have some values that they are nominal, put them in our model. These nominal variables, they have no numeric value. So they are, for example, the genders, the males and females, or the job, so or something else like this, that we have no numerical value for that. And if we want to put it in our model, we have to show the computer, the program, which part has the special meaning and how it can divide the observations to the males and females, how it can indicate this kind of variables and how we can recognize which part of the data set is for which part of that variable. So with this dummy variable, basically we do this for each value of that variable. For example, if it is gender, we have male and female, we make one column. And for that value, we put 1, for the other 0, and the opposite for the second one. So for each one of these variables and attributes, we produce some variables or attributes in the number of the values of that variable. So if it is male and female, 2 variables. If it is job and we have 4 jobs, 4 variables. And because of that, it increased the dimension of our model. It is somehow computationally expensive. And we have to take care of that these dummy variables are a solution, that we can get the variables inside of our model, but we are increasing the dimension of our model. And because of that, we have to, what is the shortcomings here? The shortcomings is we have to have more data because we need more degrees of freedom. Okay, and here we have the binding numerical variables. Some algorithms prefer categorical rather than continuous predictors, and in which case we would need to partition any numerical predictors into binds or bands. Okay, so because of that, we need the binding because of some algorithms, and for this binding, we have some methods. We have the equal width, we have equal frequency. We say that the frequency should be equal, so we have here we have 4, here we have 4, and here we have 4. But here we have the equal width, so this width is important, this width is important, and this width is important, and we divide them like this. And also we have the algorithm of k-means that is here, the k-means clustering. It's somehow better than the others. And we're classifying categorical variables. It is the algorithm performed suboptimally when confronted with predictors containing too many values. So we reclassifying the categorical variables to decrease this amount of values in one variable. And adding an index field. This index field is very important. This is the basic action that we have to do when we get some kind of the data set. And what is that? We add one column and then start from 1 to the last number of the observations, okay? So we put kind of index that it indicate the position of that row in our original data set. Why is it important? Because when we start to analyze that data set, we do a lot of things on that data set, and sometimes we reorder the variables, okay? Because of some purposes, we want to see something in our data set, and we lose the original order of our data set. And sometimes that original order is important because we want to review something, we want to get another data from our data set, we want to communicate with the people that they gave us our data set, and we don't know which row they are talking about when they want to transfer us some information or they want to revise some rows. So it's important to put one variable and then put one index, but there is something that we should take care. This variable is not going to include in our model, right? So this is something, there's some benefits, and we have to also take care that we don't put it in our model as a variable when we are doing the modeling. And the variables that they are useless, we have to remove them because of any reason that we have, and variables that should probably not be removed. There are some variables that maybe they are very important, or we don't have any reason that they are missing systematically, and they are not missing by purpose. So we have to estimate them, and we have to put them in our model, even if we have only 10% of that data, and we have the 90% of that variable as missing. We have to do something about it, okay? And we have to treat it somehow. Okay, the duplicate records should be removed. It's clear. And the ID field that we have to take care to not consider it as a variable. All right, so far so good?
Yeah.
So I want to add this part. If you have any question or anything to discuss, we can go now for discussion. If no, I can continue with some points about these materials that I already provided for you. No question?
Just when you use nominal variables, how do you identify the outliers? Because sometimes although you do the flagging, or if you alter the characteristics of the variables so that they may be more understandable and processed, I think it is still difficult to identify those that are outliers, because sometimes even if when you are in the core of the business, it sometimes can be difficult to define a rule to set who are the outliers in the nominal variables. Do you have any advices?
Very nice point, Renato. It's a very important question. When we are talking about outliers, the main concept is the distribution. So we have a kind of distribution that we try to find out about the shape of that distribution based on the observations, okay? And then we look at the other observations that they are far from the regular data that we have in our data set, and we candidate them as outliers. So this is something about the distribution. If you think about distribution, then you will find out that for nominal variables, we don't have the continuous distribution. It's a kind of, for example, the binomial distribution. It's 0, 1, or for example, if it is the gender, it is 0, 1, and anything out of this would be error. It's not any more outlier. And for this kind of variables, mostly easily we can look at our data set and then see that, okay, this part is not anything related to males or females. Okay, this is something else, and that is error. I can remove it. The main problem of the outliers will be for the variables that they are continuous, and we have a kind of distribution, and we want to see if that part of the data that they are outliers are going to make some bias or increase the variance of our main distribution, and they are not relevant to that distribution. Maybe they are coming from some other distribution. That distribution is very close to it, to this one that we wanted, but it is not the same. That is for another one. In this case, we want to remove some of the variables and some of the observations, and we consider them as the outliers. We call them outliers. So basically for the variables with the scale of nominal, we have some levels, for example, male, female. We have some jobs, okay, these are the jobs. We have some diseases, so we have the name of those diseases. So we know this, and everything out of this would be an error.
For example, if you are, imagine degrees of education. If your main population is with the first or secondary degree, and imagine if you have a PhD at your dataset, it can be identified as an outlier, or you keep using it even if it is only a little part of the dataset?
No, it cannot be considered as an outlier because it is related to your strategy to gather your data. So if your sampling is good, if the reliability and validity of your research tools are good, and if the sampling methodology is fine, the number of the sample is good, everything that you have seen is data. But if you see one PhD and then you go to the other variables, the other attributes, and you see that the age of this guy is, for example, 20, and then he said that he is PhD, so in this case, we have to go and investigate. If we don't have any evidence for that, this is a kind of data we should keep it, and it gives us some information about the population, but because the number of the PhDs are not very high in the society, we observe only one, and that is not the reason that observation is an outlier. It is something that's rare in the society, and it happens.
Okay.
I have one question.
Sure.
If we have many cases that the value is not stated because it's missing or because it's a questionnaire and the person didn't answer. So if we have a variable that is not related to the others, like what Renato said, the level of education, and we have a group of people that didn't answer, can we say that that is a possible answer, or should we choose to eliminate those records, or should we deal with them in other ways? Or my question is, can we just assume that it's a non-answer or not?
What's your idea on that? What do you think?
While dealing with missing data, so far I have no I have no training or on dealing with data. I would say that though that data is to consider, but I will not transform it into other type of data using the mean or using similar records. I would just assume that it's a missing value. But I understand that doesn't work, for example, with numerical analysis. You cannot just say this is 0, because 0, it's a value that will disturb your other analysis. So my question is, with numerical, should we deal differently with numerical and with categorical? Can we assume that the missing value is a question not answered? That is my question. Because I have no training on this. And intuitively, I would just assume I don't have those values and I cannot infer anything about that. So I will not deal with them if I didn't know any better.
I think that also depends on the core of the business, because, for example, I'm from the healthcare domain, and depending on the, so it's okay. So depending on the scales that we are using, sometimes we can use the missing values, and sometimes not. It depends of really on the validation of the scales sometimes, and it also depends on the total of the population that you are using, because if you have too much missing values, sometimes you cannot use it at all, I think, because it won't be representative. Eventually, you can use that information to start to understand why they are missing values. But I think it won't be useful to imputate or use any kind of numeric attributes in those cases.
You're completely right. So if we see that we have many missing values, there is a reason behind that. Okay, maybe the question that we ask is a kind of sensitive question. Okay, or the validity and reliability of our questionnaire is not good. So in this case, the people could not answer it and they could not understand it. Or there are some concern to answer some of the questions, and because of that, it is the missing value. In this case, if we have a lot of missing values, we have to take care that these kind of missing values will decrease the accuracy of our study. And that is the main concern. And in the statistics, we say that it decreases the degrees of freedom. And degrees of freedom, basically in computer science, is information. So if you have degrees of freedom, you have information. Why we take care of the data. And we say that we should impute the missing values. because the sample size that we calculated was important for us. It's based on a measure of the error that we need to have in our study, and we don't want to go over that burden, right? So that kind of accuracy is important for us. And because of that accuracy, we have a kind of sample size. And based on that sample size, we gather the data. And if we have the missing values, what does it mean? It means that we cannot have that kind of measure of the error anymore. We go over that measure of error. And the error of our study is increasing. For this reason, the people like to impute the missing values as much as they can. They don't like to remove them because it's against of the sample size that they have and the accuracy of the study that they have. If they have also the big data, the good data is not so much. So maybe there you can remove some of the observations, but basically you have to take care that the noises in big data is so much. So maybe you remove some part of the data set based on some missing values for some attributes, but you have the values for the others, but you remove them, you remove those rows, and you miss many good information that they are not about those missing values, about the other variables in that part of data set. So this is not as simple as this, that if we have the missing values, if we impute them or estimate them, it makes some bias for us. No, it also removing the outlier or the missing values or outliers will make some kind of error for us, and it will increase the error of the model also. This is my idea. Let me tell you something about these outliers and missing values that maybe they are some important points. First, about the outliers. So we said that the outliers are something that appears to deviate markedly from the other members of the sample in which it occurs. So they are somehow far from the others. And after identifying these kind of outliers, we can welcome those outliers. Why? Because we find them the reasonable outliers, and we find them the informative outliers. So they are the part of the information that we want to get from this society, from our population. We don't want to remove them, okay? Because, for example, it is about the diseases, it's about the banking system, it's about some special cases in the society. And we can also reject them, eliminate them, and also we can impute them with some methods, right? So these are something that we know. And here, this is the first question that we should ask when we face with outliers. Okay, so this is very important to know that outliers and observations that they are far from the others are not necessarily bad or erroneous. Sometimes they are a part of our data and they are valuable, they have some information inside. Because of that, we have to know the origin of outliers first. So the first question about outliers is not which part of the data is far from the others. The first question is that what is the origin of those outliers that we can candidate them as outliers, okay? So one source is the measurement error. The other one is inherent variability of a basic model generating the data. So we have some variation in the model, so it's basically makes some observations far from others. For example, that PhD that you mentioned, it's in our society, but they are rare, so we can observe them as 1, 2, 3 in, for example, 30 or 40 observations that we have from the population. And We have also the sample level imperfect collection of our data. If we have some problems to gather the data from our population, and if we have this kind of origins of the outliers, the treatment of them would be different. We cannot put one method for all of them because they are outliers, so we can do everything with them by, for example, using only one or two methods that we know. And the source of the outlier is important to know that how we have to treat them. Okay, so some keywords about outliers is that we can use the box plots that you know, this famous chart here, and this is the source if you want to go and see, and these are the keywords that we can go and look for them, search them in Google, and if you look up it in internet, you will find the definition and how you can use it, and even the programs that you can use in R or Python. So the first one is the discordancy test. This is a kind of test that we do to find out that if one observation is really outlier or no. Okay, so this is important to go and test it with, for example, Dixon Q test, with this one, or with Thomson Tau test. So these tests are for outliers. Okay, and based on them, you can check it with the statistical methods to see that if that outlier is significantly meaningful to be outlier or no. And the robust estimates can be used if we find some outliers in our data set. All the time it's not necessary to remove them and then do the analysis. We can use some robust estimates or robust models that they are robust to the outliers, so the outliers cannot somehow make some errors for them. And basically, for example, for some estimations, and very simple, we can mention, for example, trimmed mean, Windsor mean, and robust mean, and standard deviation based on Hobart M estimators. So these are some keywords that if you want to study more, these are very good to follow because it will give you some tools to test your outliers with some statistical tools and then consider them as outlier or as a regular value. So here there is a very quick example that we have something from the bank. So here we have some values and we want to see that if we can find one outlier here or no. So basically we first we have to order the data and then do some calculations and then use some distributions like t-distribution to check that if that value is very far from the others or no, or based on the distribution, if it is normal or it is t-distribution, that value is completely meaningful and not the outlier. Here is another one. So here we have, for example, this 621 very far from the others, and we use another statistic here. So this is also the t-distribution, and based on that we calculate the p-value and we say that if this value is really an outlier or no. And for missing values, what is important is the pattern of missing data and source of missing data. So for missing values, we have two important questions. One is, what is the pattern of missing data? The pattern of missing data is the first question that we should ask when we face with missing values. The source of missing data is another one. So these are the two main questions, what is the source and what is the pattern. After that, we say that why it is important, why the missing value is important. The most concern regarding missing data is the extent to which the missing information influences study results. So it's important to know that if they are influence the study results or no. If they are not important. They can be in data set. If they are, so it's somehow related to the methodology that we are going to use, the tools of statistics or data science or data mining that we are going to use. And what is important about this influence? What do we mean when we are talking about influence? Basically, we are talking about validity and reliability. Okay, these two are important. When we have the missing values, we have some problems with the validity of our study and reliability of our study. So here I have a keyword again for you, the Welsh test. The Welsh test show that mechanism of missing is not really Makar. And what is the Makar? Makar is here. So this is the first that I told you. We have to ask ourselves, what is the pattern of the missing data? So the pattern of missing data could be Makar, could be Mar, or Manar. And these are very important. What is the Makar? It is missing completely at random. So the values of one variable are not internally correlated. They are not correlated to other variables. And the missings that we have there, they are missed basically without any reason. Okay, we don't find any logic behind of that because the question was hard, because the question was sensitive, they are missing. Okay, and they are missing at random because the people were not there. When we want to ask them, they were not at home. Okay, so basically because of that, they were sick and they couldn't participate in our study. And based on that, it's missing. In this case, we have the Makar. And here with the Welsh test, we can find the mechanism of the missing value, if it is Makar or not. The other one is Mar, and Mar is M-A-R, is the missing at random. They are missed and there is no value there. They are somehow for some group of people. For example, these missing values are related to the elderlies, to the old people, okay, to the people with the high age. And this kind of information make it somehow reasonable to think that if it is missing at random and they are not Makar, they are Mar, okay? And here we can use some methods to treat this missing at randoms. Here maybe the best one for Makar is to remove those data if it is not important, or if we have many samples, so we have many data, we can remove them, or we can impute it with any kind of random methods that we like because it's Makar. There is no relation with anything else, but here we have a kind of relation. And if it is not Makar or it is not Mar, it is Manar. So the Manar is something that is not these two. It means that it's missing because of some problem. And basically for Manar, we don't have a reasonable way to impute them with something because they are missing by purpose. So here we have another keywords about the substitution and imputation. So you can see that mean substitution, median substitution, random value imputation, hot-take imputation, randomly selected the value from the observed data, cold-take imputation, use values from another data set to replace missing values. So here we have another data set that we can get the data from that and impute here. And non-randomly value imputation using a classification variable in the data set, and deductive imputation, and regression imputation if we find some correlation between that variable with the others, or the time series imputation if we have the time series and our data is related to the time and we have a dimension of the time, then we can impute it based on the time series modeling. But in regression, we have to take care about one important point. If you use the regression and you are using the models with the target variable, what do you think? If we find a good correlation between the target variable and our variable, or our independent variable and our dependent variable, can we use this correlation and a kind of regression to estimate the missing values?
I don't know, but it doesn't sound like a good idea.
I think you shouldn't use it because it will increase the dimensionality and it won't be useful for the distinction between the to the prediction because it is correlated already with the variables.
So if we say that they are correlated, basically they are correlated. Why we don't use this correlation? We don't want to put it in our model that increase the dimension. We only want to impute the missing values. And we have one variable as the response variable that is highly correlated with our missing variable, the variable that has some missings. So why we don't use that, this kind of information that we have already in our data? So the question is this, that there is a good correlation between these two, and only we want to use it to impute the missing values.
If you have already a good correlation, you'll use just one of those variables to the final prediction.
No, one of them is target variable, one of them is independent variable.
Okay.
So the target and the variables that we have in our model. We know that there is a good correlation between these two. Why we don't use it?
Because we are going to influence the correlation between them.
Exactly right. Exactly, Anna. So if we use this correlation, we are somehow artificially increase the correlation because we are using this relation, the relation between the data that we have already seen, to increase the correlation with that variable with one of the variables in our explanatory variables. Finally, we want to make a model. And what is the model? The model is the relation between these two. And if in the primary work, we use this correlation to make some interpretation about our data set, we are changing the mechanism of the data. We are changing the distribution of the data based on this correlation. And because of that, this is one thing that we should take care if we are going to modeling. We have to think about this, that the target variable should be put aside to put it in our model, and the other variables that we have, maybe they have some correlation, and then we can use it as the regression, for example, method to impute the missing values. But here we have one another concern, and that is the multicollinearity. So we have to take care of the correlation between the variables, the independent variables, if we want to use some methods like linear regression, and we have the concern of the multicollinearity here. And the time series is clear. And these are the methods that we basically use. So that was totally the discussion of this chapter about the missing values and outliers and the methods that we have, the things that we should concern about them before we treat them. Sometimes in the classes, maybe we hear that we have to treat the missing values anyway. If we have the missing values, put the mean or median in your data set. But it depends that if it is Makar or it is Mar or it is Menar. And if it is Makar, the mechanism is completely different. If it is Mar, yes, we can use some of these methodologies. And if it is Menar, there is no action there. It basically tells us that data gathering has some problems. The data is not good. If you impute it, you are making a problem bigger. And the problem here is something basic. It's for the survey that we already designed it. And if it is Menar, then we cannot do that. And there are some ways to find out that if your missing values is Menar or Mar or Mekar. And then if we find out that it is Mar or it is Mekar, then we have some methods, some special methods for each of them to impute them.
So just to resume, if we do this Welch test and the result is that the missing value is not Makar, the best things to do, it's not to use the data?
No. You have to check it that if it is mar or no.
How can we check if it is mar or not? The Welch test only works to see if it's not makar, but it can be either mar or manar.
Exactly. So here you can see that, for example, if missing of one variable is related to another one, like wage and marital status, but we can control for this conditional variable by a model, and we can impute the missing values, okay? So the type of the missing is at random, okay? So we find some relation between these missing values and the other values, but this relation will not give us any clue that the information that we gather is incorrect, okay, or they are false. But sometimes we will find that there is a mechanism behind of that, because the people that they, for example, you are studying some problem about the society, and basically the people that had those kind of problems, they didn't answer you. So you will find out that these missing values, they are completely related to the part of the society that they are, for example, with some specific characteristics, and they didn't answer you. In this case, if you impute the data based on the other people in the society, you are removing them, the information of them, and the goal of the study is them, right? So basically, in this part, we can find some evidence that this part of the data set that they are missing, they have some pattern, okay? And this pattern show us that this part of the data set is related to some special cases that we observe. In this case, we said that the missing values are manar, and why it happens? Because the question that we ask is very direct, is somehow sensitive, it hurt the people that they wanted to answer, and we missed the information that we liked to observe. But here we have some evidence of the correlation, but that is very normal. This correlation exists in the real world, okay? For example, about the ability, the physical ability and the age. We find that these two are correlated, but basically, yes, based on the literature review, based on the science, they are related. And here we say that it is not completely at random, but it is at random, and we can use some modeling to impute this kind of data.
Yes. Mm-hmm. Okay. So only manar, we should not complete the missing values.
Basically, if the number of the missing values are too high, it's a lot of missing values in your data set, and the missing value is manar, it means that you could not gather enough good information and enough good data from the population. And in this case, you cannot do your study. But if the number is not too high, it depends. It depends to the method that you are going to use. Sometimes you gather, for example, 500 samples, and then for your study 100 is enough, and you have some missing values in this case, and they are manar, you know it, but you already have seen enough observations from that part of the society or the population that you need. In this case, no.
Sorry, just one more question. But if we have the majority of a variable returning missing data, we should not use that variable to start with, right? So we have information, records in lines and variables in columns. If for one variable, for one column of information, we have the majority of data returning missing values, we should, to start, eliminate that column of data, or I mean that variable.
Based on the book, I showed in the book that there was one sentence that said that even if you have a column with 90% of missing values, and only you observe 10%, and that part of information and that variable is really important for your study, you cannot remove it. And you have to treat it somehow. For example, one
90% based on 10%, that's...
Yeah, there are some solutions. No, this is not only to go forward and use your data. For example, increasing the sample size. Okay, this is one solution. You can go and get the data again, or return to those people and ask them for the reply for that question. Okay, so these are, and there are some other methods that we can use also. If we have some other, for example, we have some secondary data or secondary sources, the administrative sources, that we can get some total information and we can estimate that part of the society that they didn't answer us, but we can make some correction to the estimation of that part. Then we use the administrative data. Maybe we have some other sources of data that they can help us to get that part and impute it. Or increase the sample size, and many other solutions for this kind of thing. So it's not only this, that if you don't have data, go forward and do your analysis with only 10%, it doesn't make sense. Especially in machine learning algorithms, that they are sensitive to the sample size. So if the sample is not high enough, the model is not working very well. And they need a lot of data to train and test and do the validation. All of these parts need some data. Here.
Okay, so it's you have to look at the case.
Exactly.
In the end of the day, you have to look at each case, each variable. Oh.
Exactly, Anna. I wanted to make clear this part because in the book it was written 70%, 90%, 80% sometimes of all process of data analysis is about data preprocessing. And the people say that, oh, it's very easy, but the software do this for us. So I did a lot of analysis and I didn't put a lot of time for that. Only select this part or copy and paste this Python code and everything is there, okay? Do your job. And that is not the case. And because of that, some models are not good for the real projects. And the people see that it's not working. It is working for that part of the data that they already have for training and test, but when they deploy it in the real world, it's not working anymore. And what is the reason? The reason sometimes is going to the pre-processing and the data that we ingest in our model to train our model. This is very sensitive work. And because of that, if you remember from the first session, we said that the business is very important. The people that they are coming from business is very important. When, for example, a doctor is studying data science or a businessman is studying data science, it's completely different with somebody that has no idea about the business in the real world, because they know the nature of that business, so they know what is happening there. They have some sense to the numbers. When they look at the characteristics of a patient, they can understand that if it is a normal case for cancer, for example, or no. But a very pure data scientist has no idea about these kind of things. And they made a lot of mistakes, but nobody can understand it, because when you make the model, nobody can understand that you had some problems in your modeling.
One last question, I hope. In the SAS class, in the class that the teacher showed how SAS works, she said that we can input some coherence rules into the model. Like taking Renato's example, you cannot have 20 years old and have a PhD. Should we look at these problems in this phase, or should we put all data in the model and then put some of these rules in SAS or whatever program and just hope that Sage brings those errors to expose those errors.
Exactly, we do this. Yes, we put some limitation for the variables. If we know what is the minimum and maximum, for example, for age, it's impossible to have the negative value. So basically, we put some conditions in our program, okay? And in the real projects, when you go, for example, to work for the big companies, and you want to participate in the interviews, in the professional interviews, they will give you the opportunity to write a program, but your program should be robust. It should be, it should check everything before going forward. So you have to put some limitations for your variable to check your variables, everything that any kind of the data that they ingest in your model would not crash, and it can manage it. If it has the negative numbers, if it has the ages over, for example, 120, if something has some, we know that these two variables has some correlation, so we can use the values of one of them to check the other one. And all of these are the data preprocessing of the program that we can put there. And also some programming codes to check that if the data is not available for that variable. Because sometimes we make a model with some variables, and then from one time, for example, after COVID, the transportation will be closed. Okay, so there is no more cars in the highways, and one of the variables in our model is the number of the cars in the highways, and then the model will be crashed. The accuracy of the model will decrease. Okay, so all of this should be checked, and these are all by programming. We do it by programming. Exactly. Okay, thank you.
Thank you.